Welcome. In the last lesson, we learned the sine, cosine, and tangent ratios of given angles in right triangles. In this lesson, we're going to learn the reciprocals, which they give a special name to. So the cosecant is the hypotenuse over the opposite. In other words, it's the sine flipped upside down. The secant is the cosine flipped upside down. So notice the cosine of A is adjacent over hypotenuse, but the secant is the hypotenuse over the adjacent. The tangent of A is the opposite over the adjacent. The cotangent of A is adjacent over the opposite. There's not really an easy way to remember the cosecant and the secant. The cotangent's pretty obvious, cotangent, tangent. But the secant and the cosecant, students tend to get interswapped. So I would just write these 6 ratios down, these 6 trig functions. And now as we go to do this, secant of Q, I'm going to find Q. I'm going to identify the hypotenuse. I'm going to identify the adjacent side. And I'm going to identify the opposite side with respect to that angle Q. And now it's asking for which trig function? The secant, that's the second one here. So it's hypotenuse over adjacent. Hypotenuse over adjacent. It's 17/8. So that's what I would type in. So pause this video for just a minute and write down these ratios on a piece of paper because we're going to refer to them quite frequently as we work through this. So again, we're going to look for the cosecant of G. So I'm going to first find G, and then I'm going to identify the hypotenuse. I'm going to identify the opposite side, and I'm going to identify the adjacent side, and then I'm going to find the cosecant, which is the reciprocal of the sine. I don't know, that's just the way I remember it. So instead of being the opposite over the hypotenuse, it's the hypotenuse over the opposite. Hypotenuse over the opposite. And that's the cosecant. Again, hopefully you've written that down and you're referring to that. So again, in my ratio, I just do the hypotenuse, which is 53, and I put it over the opposite side, which is 45. I do try to always remember to reduce if possible, right? Like this one I can see is going to reduce very quickly. Cotangent of G. So here's G, here's the hypotenuse, here's the opposite, and here's the adjacent. And the cotangent is the reciprocal of the tangent. So instead of opposite over adjacent, it's adjacent over opposite. So it's 16/30, but that reduces by at least a factor of 2, which is going to be 8/15. So that's what we type in, is 8/15. Now again, notice that we will have some that have square roots at a certain point. So just remember to rationalize your denominators and to reduce your radicals as much as possible. Here's one where we have to perform Pythagorean's theorem. So don't forget how to do Pythagorean's theorem. I'm going to go a squared plus 5 squared equals 13 squared. So a squared plus 25 equals 169. A squared equals 144, because that's 169 minus the 25. A then would be 12. Now that I've used Pythagorean's theorem to find this length of side 12, I go to find the cotangent of C. Here's C. So this would be the opposite. This would be the adjacent. And the cotangent is the reciprocal of the tangent. So not opposite over adjacent, but adjacent over opposite. It's 5/12. So I type in 5/12. I'm going to do this and just see if it works. 5/12. And look at that, it works. So you don't actually have to do it. All right, I'm going to jump ahead. Okay, I found one with some square roots. I wanted to again emphasize that I've done a squared plus b squared equals c squared, or Pythagorean's theorem, to find the missing side. Just remember, the c is always the hypotenuse. These are a and b. It doesn't matter which is which. So I made this a and the unknown value b. when you square square roots, remember it cancels the square root, but I do square the 2, that's 4. Square the square root of 6, that's just 6. And then here I square the 4, that's 16. I square the square root of 2, which is 2. 4 times 6 is 24. 16 times 2 is 32. Minus the 24, I get b squared equals 8, or b is the square root of 8. But then I also reduce this, because the square root of 8 is 4 times 2. So that factor of 4 can be square rooted to a 2 on the outside, leaving that single 2 on the inside. So the missing side is 2 square roots of 2. Now I'm ready to do the cosecant. Cosecant of v. So I first find v. That means this side up here is my opposite. This side here is my adjacent. And my hypotenuse is this side. And the cosecant is the reciprocal of the sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So it's going to actually be 4 square roots of 2 over 2 square roots of 2, which is actually really nice because the square roots of 2 cancel. 4 goes into 2 twice, so my ratio is just an integer. It's just 2. But now, if it didn't reduce like that, I would have to rationalize the denominator. And if you need a reminder on how to rationalize the denominator, please do ask me in class. And I will talk to you then.